So this is a talk I gave at the Science Online conference, Science Online 2010 down here in the Research Triangle. It was a great fun, so much fun. I recommend anybody who has the chance to get to the next Science Online conference to show up. This is an Ignite talk I gave at the dinner tonight, and it was supposed to last 5 minutes. So it's not going to be as much fun giving this now because it's not to a live audience, but nevertheless I thought it might be worth doing again. So this is all about crowdsourced chemistry and why online chemistry data needs your help. So there's a lot of stuff online that you just have to be aware of. It really helps you understand chemistry. Chemistry is dangerous. Everybody tonight was sitting at the dinner and they were drinking dihydrogen monoxide. Don't they realize just how dangerous it is? This website will tell you that. You can even send email to your representative. Look at this. Tell your politician, your local politician, your national politician, just how bad things are. DHMO, dihydrogen monoxide. Scary, scary stuff. Dihydrogen monoxide, what would that be? I mean, really, a couple of hydrogens, one oxygen, H2O, that's water. Why have we got a website that warns us about dihydrogen monoxide? Well, because this is just a hoax. If you go to Wikipedia, it's all on Wikipedia. Dihydrogen monoxide hoax. This went on to show just how confusing chemistry is to people. I recommend going to the site and checking it out. This was a 14-year-old student who gathered petitions to ban DHMO as a basis of his science project. The project was called How Gullible Are We? My recollection is 47 out of 50 students signed it. There's also a lot of stories about politicians trying to get DHMO removed from manufacturing processes. Go read it on Wikipedia. It's a great place to get information. Now, chemistry on the internet overall is messy. Chemical structures, which is what we're going to talk about tonight, is very, very messy. In fact, if you stood behind this guy, this would be messy. Why? Well, of course, greenhouse gases, and it's methane. Methane? What's methane? Methane's a simple compound. We know about methane. We hear about it all the time. This couch here certainly made a boom. What would it be with? Well, it would be with this stuff. Let's go back to Wikipedia. Great place for the man on the street to search about chemistry. Here we see methane. 1 carbon, 4 protons. Nice little detailed article about methane. By the way, that is correct. That is the right structure of methane. Now, if we go to PubChem, PubChem's an interesting database that you can go search. One of the most interesting out there. Large data sets, assay data, running over at the NIH. Why have they called it charcoal? Maybe if you threw a little bit of methane on your barbecue instead of charcoal in the summer, you'll get that type of effect. What a great way to speed up your cooking a cow. What else would you get on the PubChem compound about methane? Well, here's some names associated with methane. What else is methane according to PubChem? Charcoal. What's that? Diamond? PubChem thinks it's diamond. Well, that's interesting. Sure enough, if you do a search on PubChem for diamond, you will end up at methane. Does that mean I can love you with a methane molecule, passing gas onto a gold ring and hand that over at Christmas? Maybe a buckyball or two. That's also on PubChem. Search on methane, you'll find buckyball and fullerenes. Maybe soot. Anyway, baby, I love you. Chemistry is really messy. When you see complex chemical structures like this is a very well-known antibiotic sitting on Wikipedia. This is vancomycin. How would you know it's right? Did the person who put it here draw it correctly? Well, I can tell you we've been working on validating all the chemical structures on Wikipedia for a couple of years now. We've worked very hard to curate what's on there. Chemistry might be messy, but it's very clean on Wikipedia right now. However, let's go back to PubChem for a moment. Search on vancomycin will turn up multiple pages of data. PubChem's not the only database that has this issue of needing curation. There are many databases out there, tens at the moment, that contain a lot of data that people are starting to use and reference. Well, who's going to curate all this information? How will you clean a large data set of millions of compounds? Let's trust the FDA for a moment. The Food and Drug Administration, they're responsible of taking care of us. This is a website called DailyMed where they put information about tablets. This is the tablet label. There are many thousands of them on DailyMed. You have to trust the authority, right? Let's take a look at this chemical structure right here. Not too bad. Nice little story about the compound in question. Well, if we look at other labels, what we find is we see this type of compound. Oh, there's a few bonds missing there. This is actually the correct compound. By the way, this one's got stereochemistry, as you can see by these wedge and hash bonds. This one just has bonds missing. Bonds are kind of important in chemistry. Whatever they tell you, you need bonds for real chemistry. It's also better to have an entire molecule. Look at this one. This is supposed to be the molecule in question. Here again we have something, maybe hand-drawn. Certainly not using software. And by the way, we do seem to have lost the part of this ring. Rings, they're kind of important to have when you're talking about high-quality chemistry. Does stereochemistry matter? Well, these are the molecules we get off of another article on DailyMed. These are the real chemicals. Does stereochemistry matter? Of course it matters. One stereocenter matters. These are the two enantiomers of thalidomide. This one over here causes this particular problem here. Stereochemistry is essential. You've got to get it right for chemistry. Now one would assume that experts will get it right. People who write detailed web pages containing information about things like domoic acid poisoning. This is a toxin. Shellfish poisoning. It's a dangerous little beastie. You'd think that this website dedicated to domoic acid, written by the experts, would be right. Afraid not. That molecule is wrong. Also, it was wrong on Wikipedia. We've cleaned it up. It's curated. It's right on Wikipedia now. What's this? These molecules are the same. This is in C&E News from the American Chemical Society. This molecule's also incorrect. Why? Oh, look at that. Copied directly from Wikipedia. This showed up on my blog where one of the senior editors from C&E News came along and said, yep, we are sourcing information from Wikipedia. And they would love to have an open source of information that they can reuse. This is actually the correct structure for domoic acid. So online chemistry is dirty. It's very dirty, in fact. When you look at millions of compounds, you're going to have a lot of problems to clean up. Wikipedia structures are very good. There's been a curation team of many people working on them. We've been working on them for 2 years at least. Chemistry databases as a whole are polluted. They have to get cleaned up. So, if online chemistry needs curating, who's going to do it? Well, we say the crowd. The wisdom of the crowds has to be engaged to curate chemistry. That's how Wikipedia grew. It's a crowdsourced database. The crowd is building it. People with different skills are putting all of their information that they know, all of the data that they've gathered up onto Wikipedia, and it gets curated by an entire team of people, the crowd. We're using the same approach here on ChemSpider at chemspider.com. At present, we've got 23.5 million chemicals, unique compounds, from 300 data sources, and it's an open platform for deposition and curation. We allow people to come and deposit their own compounds, to add data such as spectral data, properties, synthesis procedures. We also allow them to curate what's already on there. We've been doing this now for about 3 years, and the data are a lot cleaner than they were to start with. Our hope is, as we continue to do this, we'll build a foundation for the internet chemistry databases to reference back to. Come along to ChemSpider. We'd welcome you to check it out.